maintenance switch at the switchgear breaker offers a practical solution for safely accessing and troubleshooting variable frequency drive, or VFD, cabinets. Its primary advantages include convenience, safety, and improved coordination. Firstly, convenience is greatly enhanced because the switch provides a single point of isolation, eliminating the need to disconnect multiple VFD breakers individually. Secondly, safety is improved because it ensures that all power is safely disconnected from the VFD before technicians enter the cabinet, reducing the risk of electrical shock. Thirdly, coordination becomes more manageable as the switch allows controlled isolation of the VFD being serviced, while maintaining power to other VFD connected to the same breaker, minimizing disruptions. However, the use of a maintenance switch also presents potential disadvantages that must be carefully considered. These include potential downtime, increased system complexity, and the inherent reliability concerns associated with any mechanical switch. Firstly, downtime is a significant consideration because isolating the breaker at the switchgear will interrupt power to all VFD connected to it, potentially impacting production or other critical processes. Secondly, increased complexity arises from the additional wiring and components required to install the maintenance switch, which can add to the overall complexity of the electrical system and potentially increase the likelihood of failures. Thirdly, reliability is a concern as the maintenance switch, like any mechanical component, is subject to potential failure, which could lead to unexpected power interruptions and disruptions. To effectively mitigate these disadvantages, several strategies can be implemented. These include careful planning for downtime, incorporating redundancy into the system, and conducting thorough and regular testing of the switch and related components. Firstly, to minimize downtime, maintenance should be scheduled during non-critical hours or periods of low production. Temporary power sources can also be used to maintain power to critical VFD during maintenance activities. Secondly, to enhance reliability, redundant breakers or switches can be installed to ensure that the failure of one component does not result in a complete loss of power to the VFD. Thirdly, regular and thorough testing of the maintenance switch and its associated components is crucial to ensuring proper functionality and identifying potential issues before they lead to failures. Beyond the practical considerations and potential disadvantages, several additional factors should be taken into account when deciding whether to install a maintenance switch. These factors include compliance with codes and regulations, proper training of personnel, and clear labeling of the switch and its associated equipment. Firstly, it is essential to ensure that the installation and use of the maintenance switch comply with all applicable electrical codes and safety regulations, such as those outlined by the National Electrical Code, or NEC, and local jurisdictional requirements. Secondly, authorized personnel must receive comprehensive training on the proper use, maintenance, and troubleshooting of the maintenance switch to ensure they can operate it safely and effectively. Thirdly, the maintenance switch and all associated equipment should be clearly labeled with detailed instructions for its use, as well as warnings about potential hazards. An example, NEC Article 430.102. B covers motor disconnects, while 430.74 and 430.75 cover the marking requirement. Article 110.21 covers marking requirements for all equipment. Regarding the National Electrical Code, or NEC, some sections might indirectly relate to the installation and safety of maintenance switches used with VFD, even though the NEC doesn't specifically call out maintenance switches for VFD. Always refer to the latest edition of the NEC and consult with a qualified electrical inspector or engineer for specific requirements in your jurisdiction. Here are some potentially relevant articles. NEC 110.3 covers examination, identification, installation, and use of equipment. This section requires that all electrical equipment be installed and used according to the instructions included in a listing or labeling. It emphasizes the importance of following manufacturer's instructions, which would be very relevant for a maintenance switch installed with a VFD. NEC 110.16 covers arc flash hazard warning. This section requires that electrical equipment likely to require examination, adjustment, servicing, or maintenance while energized be field marked with a warning label to caution qualified persons about potential arc flash hazards. If the maintenance switch is intended to allow work on a VFD while parts are still energized, this labeling is crucial. NEC 230.70 A1 covers the location of service disconnecting means. While this section primarily deals with service equipment, the underlying principle of having readily accessible and clearly marked disconnecting means is applicable to maintenance switches for VFD. The intent is to provide a way to quickly de-energize the equipment in case of emergency or for maintenance. NEC 430 covers motors, motor circuits, and controllers. Article 430.102 B specifies the location requirements for disconnecting means. A maintenance switch would need to comply with these requirements to ensure it is accessible and appropriately located. NEC 430.109 covers types of disconnecting means. This section lists the acceptable types of disconnects for motor circuits. A maintenance switch would need to be a listed and labeled device suitable for use as a motor circuit disconnect. NEC 430.110 covers the rating of disconnecting means. The maintenance switch must have an ampere rating not less than 115% of the full load current rating of the motor. NEC 430.128 covers adjustable speed drive systems. This section requires specific marking and disconnecting means for adjustable speed drive systems, which include VFD. The maintenance switch would need to be integrated into the system in a way that meets these requirements. NEC 430.130 covers overhauling or backfeeding. This section requires that adjustable speed drive systems be equipped with a disconnecting means that will disconnect the motor and drive system from all ungrounded supply conductors and possess provisions for locking in the open position. This is highly relevant for a maintenance switch intended for safe servicing of a VFD. NEC 430.201 through 430.207 covers motor control circuits. These sections provide requirements for control circuits used with motor controllers. If the maintenance switch affects the control circuit of the VFD, these sections would apply. NEC 670 covers industrial machinery. This article applies to electrical equipment used in industrial machinery and includes requirements for disconnecting means and control circuits. If the VFD is part of industrial machinery, this article would be relevant. The use of a maintenance switch must allow for compliance with the requirements in 670. NEC 70E is the standard for electrical safety in the workplace. Although not part of the NEC, compliance with NFPA 70E is often mandated by OSHA and other regulatory bodies. NFPA 70E provides guidance on safe work practices, including lockout/tagout procedures, which are directly relevant to the use of maintenance switches for VFD. It is crucial to follow proper lockout/tagout procedures to ensure the safety of personnel working on or near electrical equipment. NFPA 70E, or the National Fire Protection Association 70E, is the standard for electrical safety in the workplace. It provides guidelines and requirements for safe work practices when working on or near electrical equipment. This standard is not part of the National Electrical Code, or NEC, but it is often enforced by OSHA and other regulatory bodies to ensure workplace safety. NFPA 70E outlines specific procedures and requirements to protect employees from electrical hazards such as electric shock, arc flash, and arc blast. Lockout/tagout, or LOTR, is a critical safety procedure defined in NFPA 70E. It involves de-energizing electrical equipment and applying locks and tags to prevent accidental re-energization while maintenance or repair work is being performed. This is directly relevant to the use of maintenance switches for VFD, as the switch should facilitate proper lockout/tagout procedures. NFPA 70E requires employers to develop and implement a comprehensive electrical safety program that includes elements such as hazard assessment, training, and the use of personal protective equipment, or PPE. Hazard assessment involves identifying potential electrical hazards in the workplace, such as exposed live parts, and determining the appropriate safety measures to mitigate those hazards. Training is essential to ensure that employees are aware of the electrical hazards in their work environment and are trained in safe work practices. This includes training on lockout/tagout procedures, the proper use of PPE, and other safety measures. NFPA 70E requires the use of appropriate PPE when working on or near energized electrical equipment. The type of PPE required depends on the specific hazards present and the voltage levels involved. Common types of PPE include arc-rated clothing, gloves, face shields, and safety glasses. NFPA 70E defines approach boundaries to energized electrical equipment. These boundaries include the limited approach boundary, the restricted approach boundary, and the prohibited approach boundary. Qualified electrical workers must maintain appropriate clearances from energized equipment based on these boundaries. NFPA 70E provides guidelines for establishing an electrically safe work condition. This involves de-energizing the equipment, verifying the absence of voltage, and implementing lockout/tagout procedures. In conclusion, a maintenance switch at the switchgear breaker can be a practical solution for troubleshooting inside VFD cabinets, offering convenience, safety, and improved coordination. However, it is crucial to carefully consider the potential disadvantages such as downtime, increased complexity, and reliability concerns. By implementing mitigation strategies, adhering to relevant codes and regulations, providing proper training, and ensuring clear labeling, technicians can safely access VFD cabinets while minimizing downtime and potential risks. Ultimately, the decision to install a maintenance switch should be based on a thorough assessment of the specific needs and circumstances of the electrical system, as well as a commitment to maintaining a safe and reliable working environment.